Welcome friends, 10th standard math part first. We are going to study lesson number 2, quadratic equations. Today, students, you have studied in maths part first in 9th standard, lesson number 3, polynomials. There are two types of polynomials, linear polynomial and quadratic polynomial. Polynomial having degree 1 is called as a linear polynomial. This is linear polynomial because here is a variable x and degree of this variable is 1. Therefore, this is linear polynomial. We have also studied quadratic polynomial. Quadratic polynomial, suppose polynomial is x square plus 2x plus 3. This is polynomial whose degree is 2. So the polynomial having degree 2 is called as a quadratic polynomial. If we equate this quadratic polynomial equal to 0, x square plus 2x plus 3 is equal to 0, we equate this quadratic polynomial equal to 0, then it is called as a quadratic equation. So what is meant by quadratic equation? An equation involving one variable and 2 as the maximum index of variable, then that equation is called as a quadratic equation. Now general form of quadratic equation. General form of quadratic equation is ax square plus bx plus c is equal to 0, where a comma b comma c belongs to R, means a b c and r a b c are real numbers and a is not equal to 0. Now what are the methods of solving quadratic equations? There are three methods of solving quadratic equations. One is a factorization method. Number 2, formula method. Number 3, completing the square method. These are the three methods to solve quadratic equations. Today we are going to learn what is meant by quadratic equations, that is to identify the quadratic equation, to convert given equation in its general form of quadratic equation, and to solve the equation by factorization method. Practice set 2.1. Question number 2. Decide which of the following are quadratic equations. Example number 1 is x square plus 5x minus 2 is equal to 0. See this example. In this equation, x is only variable and highest index of this variable is a 2. Therefore, this is quadratic equation. So we write in this equation, x is only variable with highest index 2. Therefore, given equation is quadratic equation. Now let us see example number 3. Example number 3 is y square plus 1 upon y is equal to 2. Multiply both the sides of equation by y. Therefore, we get y cube plus 1 is equal to 2y. Therefore, y cube minus 2y plus 1 is equal to 0. Now see this equation. In this equation, maximum index of variable y is a 3, not 2. Therefore, this is not quadratic equation. Highest index of variable y is 3, not 2. Therefore, given equation is not quadratic equation. Now let us see example number 4. Example number 4 is x plus 1 upon x is equal to minus 2. Multiply both the sides of this equation by x. So we get x square plus 1 is equal to minus 2x. Therefore, x square plus 2x plus 1 is equal to 0. Now see this equation. Equation contains only one variable as x and highest index of x is a 2. Therefore, this is quadratic equation. So we write in this equation x is only variable with highest index 2. Therefore, given equation is quadratic equation. Now let us see example number 5. In first bracket m plus 2 and in second bracket m minus 5 is equal to 0. Now simplify this equation. Therefore, m in bracket m minus 5 plus 2 in bracket m minus 5 is equal to 0. M into m square minus 5m plus 2 into m, 2m minus 10 is equal to 0. Therefore, we got m square minus 5m plus 2m, that is minus 3m minus 10 is equal to 0. Observe this equation. In this equation, m is the only variable and highest index of m is 2. Therefore, this is quadratic equation. So we write in this equation m is only variable with highest index 2. Therefore, given equation is quadratic equation. Given equation is quadratic equation. Now question number 3. Write the following quadratic equations in the form ax square plus bx plus c is equal to 0. Write the values of a, b, c for each equation. Now let us solve example number 2. Example number 2 is in bracket x minus 1 bracket square is equal to 2x plus 3. Let us simplify this bracket at first. So we write x square minus 2x plus 1 is equal to 2x plus 3. Therefore, x square minus 2x and this plus 2x here will be minus 2x plus 1 minus 3 is equal to 0. Therefore, we have x square minus 4x minus 2 is equal to 0. This is quadratic equation in its standard form ax square plus bx plus c is equal to 0. To find the values of a, b and c, compare this equation with its standard form. So we write comparing this equation with standard form ax square plus bx plus c is equal to 0. So value of a, coefficient of x square is a 1 here. Therefore value of a is equal to 1. Coefficient of x is a minus 4. Therefore value of b is minus 4. And the constant term c is here minus 2. Value of c is minus 2. Now example number 3. Example number 3 is x square plus 5x is equal to minus in bracket 3 minus x. Therefore x square plus 5x is equal to, by simplifying, minus 3 plus x. Therefore x square plus 5x, this x will here minus x and minus 3 will be plus 3 is equal to 0. Therefore x square plus 4x plus 3 is equal to 0. Now compare this equation with its standard form. So we write comparing this equation with standard form ax square plus bx plus c is equal to 0. Here coefficient of x square is a 1, therefore a is equal to 1. Coefficient of x is a 4, therefore b is equal to 4. And the constant term c here is a 3. C is equal to 3. Now example number 5. P in bracket 3 plus 6p is equal to minus 5. Multiply the bracket by p, therefore we get 3p plus 6p square is equal to minus 5. So write this equation in its standard form. Therefore 6p square plus 3p plus 5 is equal to 0. Compare this equation with standard form. Therefore comparing this equation with standard form ax square plus bx plus c is equal to 0. We get a is equal to 6, b is equal to 3 and c is equal to 5. Now the example number 6. Example number 6 is x square minus 9 is equal to 13. Therefore, x square minus 9 minus 13 is equal to 0. So x square minus 22 is equal to 0. Here term of x is absent. Therefore, we write that term as x square plus 0x minus 22 is equal to 0. Comparing with standard equation ax square plus bx plus c is equal to 0. Coefficient of x square is 1. Therefore, we write a is equal to 1. Coefficient of x is a 0. Therefore, here b is equal to 0. And constant term c is equal to minus 22. Now question number 6. One of the roots of the quadratic equation 5m square plus 2m plus k is equal to 0 is minus 7 upon 5. Complete the following activity to find the value of a k. Here we have given one quadratic equation 5m square plus 2m plus k is equal to 0, and one root of that quadratic equation is given minus 7 upon 5. By using this information, we have given one activity to find the value of k. Let us solve this activity. In box is root of quadratic equation 5m square plus 2m plus k is equal to 0. We have given that root minus 7 upon 5. Therefore, we write here minus 7 upon 5 is the root of quadratic equation 5m square plus 2m plus k is equal to 0. So, value of m will be here minus 7 upon 5. So, substitute m is equal to minus 7 upon 5 in the given quadratic equation. Now we put value of m as minus 7 upon 5. Here is m square. Therefore, we write here minus 7 upon 5 square plus 2 into m. Substitute value of m minus 7 upon 5 in the box. So, minus 7 square is a 49. Minus 7 square is a 49. And 5 square is a 25. Into this 5. So, we divide 5 5 are 25. So, we got 49 upon 5. Therefore, we write here 49 upon 5. Now, 2 into minus 7 is minus 14, and this 5 minus 14 upon 5. Now, minus plus 14 plus 49 minus 14, that will be 35. So 35 upon this 5. 5 7 are 35. Therefore, here we write 7. 49 minus 14 is equal to 35 upon 5. 5 7 are 35. So 7 plus k is equal to 0. So k is equal to minus 7. Therefore, value of k, that is the constant term in this equation, is minus 7. Now practice set 2.2. Question. Solve the following quadratic equations by factorization method. Example number 5 is 2x square minus 2x plus 1 upon 2 is equal to 0. Now here constant term is 1 upon 2 and the coefficient of x square is a 2. So we take 1 upon 2 into 2 is equal to 1. So we want two numbers such that whose multiplication is 1 and addition is minus 2. So that numbers are minus 1 and minus 1. So the multiplication of minus 1 and minus 1 will be plus 1 and minus 1 will be minus 2x. Therefore, here we split up the term minus 2x as minus 1x minus 1x. Therefore, we write 2x square minus x plus 1 upon 2 is equal to 0. Now, in these two terms, we take x common. Therefore, we have in bracket 2x minus 1. In these two terms, if we take minus 1 upon 2 common, then in bracket this x will be 2x because 1 upon 2 into 2x will be x here, and due to this minus sign this x will become plus, and we have taken minus sign out of bracket, therefore this plus will become minus and here will remain 1 is equal to 0. Now 2x minus 1 and 2x minus 1 common bracket, therefore we take 2x minus 1 bracket common, and in another bracket x minus 1 upon 2, this x minus 1 upon 2 is equal to 0. Therefore 2x minus 1 is equal to 0, or x minus 1 upon 2 is equal to 0. Therefore 2x is equal to 1, or x is equal to 1 upon 2. Therefore x is equal to 2x is equal to 1, therefore x is equal to 1 upon 2, or x is equal to 1 upon 2. Therefore 1 upon 2 comma 1 upon 2 are the roots of given quadratic equation. Now question number 7 is one activity. Complete the following activity to solve the quadratic equation. And quadratic equation is given as root 2x square plus 7x plus 5 root 2 is equal to 0. And this activity we have to solve by factorization method. Let us write the equation root 2x square plus 7x plus 5 root 2 is equal to 0. Now multiply 5 root 2 constant term and the coefficient of x square root 2. If we multiply 5 root 2 into this root 2, then we get 5 into root 2 is a 2 is equal to 10. We get 10. Now find two numbers such that whose multiplication is a 10 and addition is a 7. So the numbers are 5 and 2 because 5 into 2 is equal to 10 and 5 plus 2 is equal to 7 here. Therefore this middle term 7x can be split up as 5x plus 2x. So we write here in the first box 5x, and in the second box we write 2x. Thus we have split up 7x as 5x plus 2x. Now, in these two terms, x is taken as common. Therefore, what will remain in bracket? This root 2, then x square, 1x is taken common. Therefore, x is remain there. And 5x, x is taken common. What will remain is 5. Now, here root 2 is taken as a common. These two can be written as root 2 into root 2, and one root 2 is taken common. Therefore, one another root 2 will remain in the bracket. Here root 2 taken common, there remain 5 in the bracket. In this way, root 2x plus 5, and here also root 2x plus 5 are the common bracket. Therefore, we write here root 2x plus 5 as common bracket, and in another bracket x plus root will be there. Now this bracket is equal to 0, or this bracket is equal to 0. Therefore, we write here root 2x plus 5 is equal to 0, or this bracket x plus root 2 is equal to 0. Now here let us see root 2 x plus 5 is equal to 0. Then root 2 x is equal to minus 5. Therefore, x is equal to minus 5 upon root 2. Therefore, this value will be minus 5 upon root 2 in this bracket. And now x plus root 2 is equal to 0. Therefore, x is equal to minus root 2. Therefore, here we write minus 5 upon root 2, and minus root 2 are the roots of the given quadratic equation. Now, question number 8. Question number 8 is a 3x square minus 2 root 6x plus 2 is equal to 0. Now here constant term is a 2 and coefficient of x square is a 3. Therefore, here will be 3 into 2 is equal to 6. Split up this 6 as the numbers whose multiplication is a 6 and addition is minus 2 root 6. So the numbers will be root 6 and minus root 6. Minus root 6 into minus root 6 will be 6, and minus root 6 will be minus 2 root 6. Therefore, we split up the middle term minus 2 root 6 as minus root 6x and minus root 6x plus 2 is equal to 0. Therefore, 3x square minus this root 6 can be splitted as root 3 into root 2 into x, minus this also can be splitted as root 6 as a root 3 into root 2 into x, plus this 2 can be splitted as root 2 into root 2 is equal to 0 here. Now let us see these two terms. Here this 3 will be root 3 into root 3, and 1 root 3 will be common and x will be common. Then what will remain in the bracket is a root 3 into x, minus Here root 3 and x taken common, so root 2 will remain there. Now in these two terms, we take this root 2 minus root 2 common, so what will remain in the bracket is root 3 into x. Root 3 into x. We taken minus sign common, therefore this term will become positive and this term will become negative, and 1 root 2 will remain there is equal to 0. Now let us see, these two brackets are common, therefore we take root 3 x minus root 2, this bracket common, and another bracket root 3 into x minus this root 2 is equal to 0. Therefore root 3 x minus root 2 is equal to 0, or root 3 x minus root 2 is equal to 0. Therefore root 3 x is equal to root 2, or root 3 x is equal to also root 2. Therefore x is equal to root 2 upon root 3, or here also x is equal to root 2 upon root 3. So there are two roots, root 2 upon root 3 and root 2 upon root 3. Roots are common for this quadratic equation, therefore we write root 2 upon root 3 and root 2 upon root 3 are the roots of this quadratic equation. This quadratic equation. Now let us solve example number 11. Example number 11 is 7m square is equal to 21m. Therefore we write this as 7m square minus 21m is equal to 0. Take 7m common in these two terms, therefore 7m in bracket m minus 21 divided by 7 is a 3 is equal to 0. Therefore 7m is equal to 0, or m minus 3 is equal to 0. Therefore m is equal to 0, or m is equal to 3 here. Therefore we write 0, 3 are the roots of given quadratic equation. Now students, you have homework practice set 2.1 and practice set 2.2. Thank you.